Hello, ladies and gentlemen. Welcome back to Math 20-2, Chapter 1, Section 5, Invalid Proofs, Part 2. Now, we just talked about the definition of an invalid proof. It's a proof that contains an error in reasoning or contains an invalid assumption. Now, I ask you to put this definition in your own words. So there's a mistake in the proof, so it's not true. Now, that you have to understand. There's a mistake somewhere. You've got to find it in an invalid proof. So, moving on. Premise, a statement assumed to be true. Now, I need you to put this in your own words. Okay? Now, so I want you to pause the recording, put a statement assumed to be true in your own words. If you're having trouble with this, Google it, look it up. All right? So pause. Welcome back. Now, when I did it, I said something like starting. Oh, sorry, how did I define that? My apologies. Starting with something you think is true, but have not proven yet. Okay. That's my definition. Is this a good one? I don't know. So, here. The next one. Words, sorry. Is this an example of valid or invalid reasoning? Now, Liz claims that minus 5 equals 5. So our first step, minus 5 equals 5. Second step, you square both sides. Minus 5, bracket minus 5, close bracket squared, equals bracket 5, close bracket squared. Third step, you get 25 equals 25. So therefore, minus 5 equals 5. Now, what is the error in this deduction? You should know by now that minus 5 doesn't equal 5. And it's right here. Okay? We have a false assumption. Okay? So I call that a false assumption. Now some people point out, that this or an invalid premise. Let's spell premise correctly. Yes, sorry. Got to check my spelling. So this is a false assumption. You start off with a false assumption, something wrong. Okay? And it doesn't matter what you do, you can't prove it. And you did make a mistake here. Sorry, the mistake was starting with the invalid premise of the false assumption. Now, this leads to circular reasoning, an argument that's incorrect because it makes use of the conclusion to be proved. Now, circular reason, putting this in your own words, that's a little more difficult. So I think starting with a false premise or an error, and then ending by saying the error proven. This is arguing in a circle. Okay? So you have to be aware. You can start off from there and you prove it, but it's not true. So let's do this. Is this an example of valid or invalid reasoning? Well, square root of 3 minus x equals minus 4. You square both sides. Now bracket square root of 3 minus x, close bracket squared, equals bracket minus 4, close bracket squared. 3 minus x equals 16, minus x is 13, x is minus 13. Now, is this valid? No, it's invalid. Because right here, invalid reasoning. or invalid assumption. If you ignore the invalid assumption, everything else is correct. But you start off with a false premise or false assumption. All right, so can you find the errors? Now, what's the error in this deduction? 6 equals 6. That's our assumption or our premise. So we multiply both sides. Oh, I skipped a step in there. I'm sorry. It's not immediately obvious, so I should go 6 equals 3 plus 3. Sorry. With some of these, I skip basic steps like that. That's something you should be able to figure out. Anyway, 2.5 times 6 equals 2.5 times 3 plus 3. So then I add 1 to both sides. 2.5 times 6 plus 1 equals 2.5 times 3 plus 3 equals 1. 2.5 times 6 is 15 plus 1. 2.5 times 7 is 3. 3 plus 1 is 4. 16 equals 11.5. So what's wrong with this? If you look at it for a sec right here. Math error. It's supposed to be 2.5 times 3, which is 7.5. Foiling, 2.5 times the other 3. Okay, 7.5 plus 7.5 is 15. 15 plus 1 is 16. So you made a math boo-boo here. It happens. Now, finally, what's the error in this deduction? Well, x squared minus 2x is equal to 0. Then you simplify to x minus 2 is equal to 0, so x equals 2. What's wrong with this? Well, when we get to quadratics, I'll point out there's 2 answers to the x squared, and you made a boo-boo here. What was the boo-boo? Well, here I didn't write out that step, but divide both sides by x. Okay? You're down to x minus 2 is equal to 0. But x can equal 0. But if x equals 0, this is wrong. Remember, you cannot divide by 0. No, it's brain fart. I'm trying to remember the fancy word I used back here. Yeah, dividing by 0 is wrong. Is there a fancy word for that? It's invalid to divide by 0. Yes, that's the technical term I used. Invalid to divide by 0. Okay? Now, this leads to the key idea. A single error in reasoning will break down the logical argument. A single error in reasoning will break down the logical argument of a deductive proof. This will result in an invalid conclusion or a conclusion that is not supported by the proof. So you have to be careful. A single error screws everything up. Now, we need to know division by 0 always creates an error in a proof, leading to an invalid conclusion. And circular reasoning must be avoided. Be careful not to assume a result that follows from what you're trying to prove. All right? Now, any questions, shoot me an email. Otherwise, good luck. Work on the classwork. See you soon.